Hello, and welcome to the live class video that coincides with your Unit 1 Quiz 3 study guide. This is placed in your course right before the lesson on complete factorization, and I'm hoping that it will get you kind of caught up about what you've already learned and give you a heads up about what you're going to be looking at. So let's get started. The first question on your study guide was to find the GCF of 250 and 360 using prime factorization. This is just kind of a warm-up to what you're going to be doing in your factoring. So what I like to do is set up a tree, and I always start with the lowest prime number first because ultimately I'm trying to get to the prime numbers, and by doing it this way they come in order, makes it a lot easier at the end. I'm looking at both 250 and 360, and starting with 250 I can see that it's even. So I'm going to start by dividing it by 2. Well, 2 times 125 is 250, so I put the 125 over here on the right. I like to circle any prime number factors that I come up with because that way I know what to gather up at the end. Now 125 is not even, so it's not going to be divisible by 2 again. I can tell that it's not going to be divisible by 3 because the digits don't add up to a multiple of 3. So I'm going to go right ahead and choose the next prime number, which is 5. I know it's divisible by 5, and that would give me 25 as the other factor. 25 is a perfect square, so that is 5 times 5. So if I circle all my prime factors, I can gather them up, and when they ask you to use prime factorization, you're just going to include the prime factors, and since this is 3 factors of 5, I can write it as 5 to the 3rd power. So if somebody asked me, what is the prime factorization of 250, I'd say 2 times 5 cubed, or 2 times 5 to the 3rd power. Now let's repeat the process for 360. It is also divisible by 2. Half of 360 is 180. 180 is still even, so I'm going to try 2 again. Half of 180 is 90. 90 is still even, so I'm going to try 2 again. Half of 90 is 45, and it's no longer even, so I'm going to go up to 3. Since 4 plus 5 equal 9, and 9 is a multiple of 3, I know it's divisible by 3. 45 divided by 3 gives me 15, and 15 is still divisible by 3, and the remainder is 5, which is also a prime number. So the prime factorization for 360 has 3 factors of 2, 2 factors of 3, and 1 factor of 5. So these are the prime factorization, but that's not what we were asked. We were asked to find the GCF, or the greatest common factor. So first I'm going to sort through and find common factors. I've got a 2 in common, but the lowest number of the 2's that I have in common is just that one single 2. I don't have any 3's in common, so that's not going to be on my list. I do have 5's in common, but again, I'm looking for the lowest number of factors in each of these, and 5 to the 1 power, or simply 5, is the lowest of the exponents of 5. So 2 times 5 is the GCF of these two numbers. Even though they have a lot of prime factors, it looks like 10 is the greatest factor that they have in common. Now into factoring. This is one that you'll see on your study guide, and you'll also see it in your quiz. It looks like it can't be factored. It doesn't even make sense. All it is variables. But the first step to looking at an equation when you're looking for complete factorization is to see if there are any common factors, just like we did with 250 and 360. We don't have numbers here, but I can see right away, looking at A, that is not common between all 3, B is not common, but C is. So I can put the common factor outside a set of parentheses, divide each of the 3 remaining terms by c, and I will have factored out the GCF. ABC divided by c is simply AB. BCD divided by c is BD. And CDE divided by c is just DE. There isn't anything else I can do to this expression to factor it further without knowing the value of some of the numbers. But I knew that c was a common factor. It's kind of like the reverse of the distributive property. I've just divided everything by the same factor instead of multiplying by the same factor. Here's a very common trinomial. And the first step that you want to do is look through each of the terms to determine if there's a common factor between the 3 terms. Here there are none. So I'm going to go ahead and draw my 2 binomial brackets or parentheses. And remember, when you divide a trinomial into 2 binomials, you're going to be thinking the whole time about FOIL, where you multiply 2 binomials together to get back to that trinomial. So we're kind of undoing this with a little bit of guess and check to make sure that it gets back to where it was before we divided. There's no way to get x squared except to multiply x times x. Well, I guess you could multiply x squared times x squared, but that wouldn't work out in this situation. So I like to start out here. Now, the next step I do is I look at the sign in front of the constant at the end of the trinomial. If it is a minus sign, I know that 2 things have to multiply together to make negative 44. The only way to get a negative product is to have a positive number and a negative number. So I'm going to go ahead and put my plus sign and my minus sign. The next step is to find any factors that will multiply together to make 44. And I want them to be able to add together to make 7. Because remember, when we do FOIL, we do the outside terms, then the inside terms, and combine those 2 terms to make that middle term. So I know that eventually they're going to have to add together to make 7. Well, if I look at the factors of 44, there's 2 and 22. There is 4 and 11, and I guess I should consider 1 and 44. So between each of these sets, I know one's going to be plus and one's going to be minus, so I'm ultimately going to end up subtracting them. I know that if I subtract 1 and 44, I'm not going to get 7. Neither am I going to get 7 if I subtract 2 and 22, but I will get it if I subtract 4 and 11. Now I want to make sure that my 7 ends up to be positive. So I want to make my larger number the one after the plus sign. That way I'll be forming 11x on the outside terms, or on the inside terms, and negative 4x on the outside terms. So after my plus sign, I'm going to put the larger factor, 11, and the smaller factor will go here after the minus sign. Now I always like to check. The first term's pretty obvious, that's x squared. The outside terms, negative 4 times x. The inside terms, 11x. And finally, the last terms are negative 44. So I'm just checking. I set it up so that x squared would be a product and negative 44 would be a product. The real check is to make sure that the middle term turns out correct. Negative 4x plus 11x really does turn out to be plus 7x. So this is the correct factorization. Now, you might get a couple of problems like this where you have a leading coefficient, the one in front of the squared term, that is not 1. This makes the problem considerably more complicated, but not necessarily harder. We're going to be using the same steps. First, I'm going to look through all 3 terms and make sure that they don't have any common factors, and they don't. So I'm going to go ahead and draw my 2 sets of parentheses. But now I have some choices to make with my 8y squared. I know that I'm going to use the y and the y, but they're each going to have a coefficient. So I'm going to think about the factors of 8. Could be 1 and 8, could be 2 and 4, but that's really the only combinations that we can use. I'm looking already at this middle term. It's a pretty big number. So I'm hoping that I'm going to be able to get there by using some larger numbers and combining them in a way that is going to combine to a large number. So I'm not going to make the decision yet. I'm going to look at the problem further. Looking at the sign in front of the constant term, I see it's a plus sign. That means that I'm going to multiply either two negative numbers to get 15 or two positive numbers to get 15. I know those numbers will combine eventually to make the middle term. So looking at the sign in front of the middle term being a minus, I know that I'm going to be subtracting both of the factors of 15. Okay, now I need to consider the factors of 15. Well, there's really only two, even though 15 is a large number. It can either be 1 times 15 or 3 times 5. Now, if I start combining these terms, there's a little bit of guess and check that goes into this, but you can also kind of look ahead, and the more of these that you do, the closer you can get. So let's say I'm going to take the factors that are the most sort of towards the middle, so that when I start multiplying them together, I can get a pretty large number, but not so big as, say, 15 times 4, which would already be greater than 26, or 15 times 8. So I think my 1 and 15 are going to be out. The same with the 8 and 3, that would be 24. I wouldn't be able to add much to it if I use those, and 8 times 5 is already greater than 26. So I think I'm going to eliminate 1 and 8 as a choice as well. So I'm just going to start by putting my 2 and 4 for my factors of 8, and my 3 and 5 for my factors of 15, and see if it works. Well, I'm going to do my first terms are going to be 2y times 4y, which is 8y squared. That's perfect. And my outside terms, 2 times negative 5 would be negative 10y. Inside terms are negative 12y. And I can see right now this is not going to turn out to be negative 26. I'll just check to make sure I've got my plus 15, and I do. So I'm going to switch a couple of things around, and I think I don't need to make too much of an adjustment. I think I'm going to change my 3 to a 5 and my 5 to a 3 and redo those middle terms. Now my outside terms are 2 times negative 3, that's negative 6y, and my inside terms are negative 5 times 4, or negative 20, and I can see right away that these are going to combine to make negative 26y. So I'm going to keep these factors. I ended up with 2y minus 5 times 4y minus 3. So don't be discouraged if you don't get this right away. A little bit of guess and check is normal. Now, you had a whole lesson on special cases in factorization, so this one should really look familiar. What you're looking for when there's only two terms is a minus sign between them, because one of the special forms of quadrilaterals that we found was called the difference of two perfect squares. To make sure that this fits, the numbers have to be perfect squares, and 64 is, and so is 9. And the variables have to be perfect squares, meaning that they have to have an even exponent, and these both do. So I can go ahead and factor these in the pattern that I learned in that lesson. Remember, these factors are going to be exactly identical, but one will have a minus sign and one will have a plus sign. Go ahead and put those. Now I'm going to take the square root of 64, which is 8, and put that as my first terms. The square root of t to the 6th power is t to the 3rd power. So I'm going to put that as the variable. And just to double check, 8t cubed times 8t cubed really does equal 64t to the 6th. Then I'm going to do the same thing for this next term. The square root of 9 is 3. So that goes in the second position in the binomials. And the square root of k to the 8th power is k to the 4th power. So I'll put my k to the 4th in here, and that's it. This is the joy of being able to remember those special cases. It's not as hard as it looks when you look at those big numbers. Now, this is a 4-term polynomial that immediately says to me, I'm probably going to be using grouping. So I'm going to start out, and there's a little bit guess and check in here as well, but I'm going to start out by just grouping these in the order that they are and hope that it works out. The technique here is to group them into 2 groups of 2, then to look for any common factors between those 2 terms only, separate them out, and hopefully have a matching binomial in the end that we can factor out of that whole thing. So let's take a look. I'm looking at a cubed, that's 3 factors of a, and 6a squared. The greatest common denominator between these two is a squared, because it will go into both of these terms evenly. Dividing out a squared from a cubed leaves me with just 1 factor of a, and dividing 6a squared by a squared leaves me with just 6. Now moving to the second set, when there's a minus sign in front of it, you always have the option of factoring out a negative number or a positive number. But since I want to end up with a plus, because I'm hoping that these factors will match, I'm going to go ahead and factor out a negative 4, which is the greatest common factor between 4a and 24. Dividing negative 4a by negative 4 leaves me with just a, and dividing negative 24 by negative 4 leaves me with positive 6. So this worked out just right. If yours doesn't work out just right the first time you try it, just try a little bit different combination. Maybe you need to factor out a positive factor instead of a negative one, or maybe you need to change the order of the terms before you group them. Okay, now what I'm looking for is these matching factors. I've got an a plus 6 in this group and an a plus 6 in this group. So just like before we were looking for the greatest common factor, the greatest common factor between these 2 terms is a plus 6. So I'm going to divide both of these terms by 8 plus 6. If I divide a squared times a plus 6 by 8 plus 6, I get a squared. If I divide negative 4 times a plus 6 by a plus 6, I end up with negative 4. So nice and easy, lemon squeezy, right? Not actually yet, because you always have to look to see if there's more that can be done. And if you were on top of this, you recognize that right here I've got a perfect square, another perfect square, and a minus sign between. So this little binomial is the difference of 2 perfect squares and can be factored again. A plus 6 looks like it's pretty well finished, so I'm just going to bring it down as a factor. Put my 2 sets of parentheses for this new factorization. Take the square root of a squared and put it first. One will have a plus sign, one will have a minus sign, and the square root of 4 is 2. So now I'm looking for any other things I can do, and I don't see anything. So this is my final answer. A plus 6 times a plus 2 times a minus 2 is going to multiply together to make that big 4-term polynomial. Here I'm looking again, my first step, always look for anything that all 3 terms have in common, and I see an x. So I'm going to divide each of these terms by x and leave the remainders in the parentheses. 2xy squared divided by x leaves me with the 2 and the y squared. X cancels out. 5xy divided by x is simply 5y. The x is canceled out. And minus 3x divided by x is minus 3. Now I have a fairly tame looking trinomial. I don't know for sure if it can be factored, but I'm going to give it a try. I still have my x here, but I'm going to go ahead and write my 2 sets of parentheses. There's only one way to factor 2, and that's into 2 and 1. So I'm going to try putting my 2y and my y here as the first terms. I'm looking at this minus sign in front of the 3 though. That means that my remaining factors are going to, one is going to have a plus sign and one's going to have a minus sign. Otherwise, there's no way for them to multiply together to make 3. So here's where I have a little bit more guess and check. I don't know where to put the plus sign or the minus sign. So I'm just going to try putting the plus sign here and the minus sign here. And I'm looking for 2 factors of 3. The only thing that can multiply together to make 3 is 3 and 1. So I think I'm going to put the 3, well, my middle term is positive. So according to the rule that I told you before, that means I want the positive value to be the greater one. So I would normally put 3 here and 1 here. But I can see that this is going to be problematic. If I just multiply the outside terms, I get negative 2y. And the inside terms will be 3y. And if I combine them, they will add to 1y. Not what I was looking for at all. So I like the idea of the 2 being multiplied with the 3. So if I want to put the 3 in the position where the 1 is, and the 1 in the position where the 3 is, that means I'm going to have to change. I still want my 3 to be after the plus sign, but I'm going to change this plus sign to minus and the minus sign to plus and try it out again. Now my outside terms are 2y times 3, that's 6y, and my inside terms are negative 1 times y, or negative 1y. And if I combine those, I end up with 5y, and that's exactly what I wanted. So my final factorization is x times 2y minus 1 times y plus 3. I hope you enjoyed this review of the different kinds of factorization. The main point that I'm trying to make is look at the polynomial first to see if there's a greatest common factor that can be divided out, and then to always keep looking for one more step that's possible, and especially be alert to the special cases because they offer a shortcut to get to your final destination. Let me know if you have any questions when you call, and good luck on this next assignment and on the quiz.